So the goal on these practice problems is always to do some review of what we learned in previous class, but also to help you keep remembering things you've done in the past. When we get to those ACT, pre-ACT tests, it's all, a lot of it is skills that you've had from middle school or elementary school. And maybe we just take it to the next level in the high school classes. So what's going to happen on every practice sheet from here on out is we're going to have some review questions from the chapter, but we're also going to have some what's called a spiral review. We're going to practice some of the facts you need from the past to help prepare you for those standardized tests that we just keep having to take, right? So I'd rather have you have some ideas of test taking skills and remembering the stuff from the past and have you be even more successful on those tests. All right, so we're going to start with number 1. It says choose the nets that will fold into a cube, but I will give you a clue. There are 3. What are they? Give me one. A definitely does. Give me another one. C does as well. Give me a third. Nice. What's wrong with B? One too many boxes. We have 1, 2, 3, 4, 5, 6, 7. There are not 7 sides on a cube. So you just got to be able to recognize that. In number 2, it says, which of the following equations gives a function f of x that satisfies f of 5 equals 12? What does this even mean? Called function notation. Ideas? Yeah. Perfect. Plug 5 in for x. So you literally just had to go line and plug in 5 for every x and see which one it matched with. If you get lucky and you start with a, 5 squared minus 13, 25 minus 13 is, so it's a. Not always going to work out that the answer is a, obviously. But, I mean, you can quick look down here, 5 minus 7, you can automatically get rid of c because you get a negative number. But the key is knowing that that f of 5, that function notation means plug 5 in for x. Good? All right, if anything was wrong on that sheet, you forgot to circle something on number 1, get it fixed now. The only way you get a point for this sheet is if it is 100% correct. Anything is wrong in it, I don't give you a point. Why? We just went through it. It's like an exercise in note-taking. You just have to go back and look at your notes and make sure your notes are the correct notes. Does that make sense? Okay, when it is 100% correct, you're going to put your name on the top and you're going to pass it up. All right, so then we're going to go straight into those 1-2 notes. I will tell you a lot of what we do in these first couple days is a lot of vocabulary. It's not a very exciting lessons, but here's the deal. We all got to be on the same page in terms of the words we use this year. So I've got to go through definitions of things like points and lines and segments because that way you and I can talk the geometry language together all year long. And it's not, you know, November and you're going, what's a line? Why is she telling me this? Goes on forever. What's going on with that? So we just make sure that everybody's on the same page. Do I tend to talk fast? Yes. Remind me if I'm going too fast or if you guys because I keep putting my back to you, you just got to say, hey, Miss Swyers, I need you to move for a second. Okay? Or, hey, Miss Swyers, too fast. Just tell me. Okay? You don't have to. We're good. Just keep talking to me the whole time. Okay? All right, so a point is a location represented by a small dot and named with a capital letter. So it's going to look exactly like that. A small dot and a capital letter. When you look at one, you read it like point A. So it's just putting the word point. Space is the set of all points. It is infinite. All right, give me something that could represent a point. A location in space. Anything. In this room, out of this room. Come on, use your imagination. Turn and talk to somebody near you. See if you can think of something that would represent a point. Talk to me. What'd you come up with? Yeah. A destination, so like a city could be a point. City on a map. Yeah? Good. Give me something else. I like it. What else did you come up with? He was not the only one that came up with something. Say it louder for me. Car parked on the side of the road. If you're looking at a GPS map, that car looks like a point. One little location in space. In this room, it could be the corner. Because the corner is just one single little dot, right? Anybody got anything else? Yeah. Fish on the wall. Love it. So pretty much anything's a point, right? Yeah. A boat on a radar. Love it. Absolutely, because you're thinking of like this, the radar screen, the boat moving is just a single dot. Absolutely. Good? All right. Do you have to have all of those? No. It's just to get your mind thinking about what exactly a point is. Because when we string a bunch of points together, we have a line. So a series of points that extends in two opposite directions without end. When it's drawn out, you're going to be shocked. It looks like a line. I know, mind blowing right there. Make sure it has arrows on the end because it goes on forever without end. To be able to label it, we have a couple different things that usually show up on the line. Lots of times, a couple or more points will be labeled on the line. So I just picked two random points on the line. I put an A and a B. Sometimes we will use a lowercase letter just by the line, and that can also name the line for us. So when we read it, we can read it as line AB. But line AB is exactly the same thing here as line BA. Or line T. Just so I kind of explain my writing, I will always do the T with the tail and a cross on it so that you can tell it's a T, not a plus. So I always do that one with the extra little curve on it. Good? Okay. When we use that as a symbol, it's going to be the letters that we used on, or the points on the actual line, and then we put a line over the top. Order doesn't matter because this is going on forever in both directions. So you could write it as line AB, you could write it as line BA. When we write, or when we talk about it with the lowercase c, you actually write the word line T. There's no symbol if you're just using one lowercase letter. All right, give me something in this room that would be a line. Yeah. Top of the whiteboard. Now, technically, the top of the whiteboard ends, right? But we're going to visualize it continuing on out, going all the way across the room. What else? Yeah. Floor tiles. There's a line along the floor tiles, or where they meet, that goes on all the way across the room. Yeah. Say it one more time. Floorboard? Okay, what do you mean? Oh, that. Got you. The thing along the edge of the wall, the floorboard. I was totally not thinking that way. But yes, that is 100% a line. Nice work. All right, why do you think we use double arrows to name it or draw it? Yeah. Perfect. Goes on forever, and we got to show that with the arrows. Good? Anything else? Okay, so in that next picture, you have 3 different lines. We have line M, which is, I'm just going to highlight it up here with my blue. This one is line M. I want you to name that in as many ways as possible. You're going to turn and talk to somebody next to you. So not getting up to do this one because I don't want it to take that much time. But turn and talk to someone right near you, making sure no one's left out, to come up with as many names for that line as you can. And I want you to remember right above how many letters you got to name it with. Ready, set, go. Look up above where it shows you how many letters to use in the symbol. Symbol for line, how many letters? 2. I'm seeing a whole bunch of 3s out there. You only use 2 letters to name a line. It does say as many as possible. I'm seeing people stop after 2. There's more than 2. Anybody don't want to see how many or say how many they got yet? I got a 4 back there. I got a 5. I got 6s. Anybody higher than 6? So you're shooting for 6. See what you can find. All right, somebody give me one. EF. And then I put the symbol over the top of it. Give me another one. See what? Yep. Give me another one. Okay. Give me another one. Yep. Give me another one. Nice. Give me another one. Now, I organized them up here so they were right next to each other. You don't have to do that. It doesn't matter. You're just doing a line of names. But the basic gist is 2 letters at a time, and we can flip them over. So it doesn't matter which direction you give them. Good? Okay. So remember, I've talked about quizzes and things. On a quiz, something like this, you would get a point for naming each one, and then you get a point overall for remembering the line symbol on it. So symbols add up during the course of a test. Angle symbols, line symbols, we'll get to segment symbols. All those over the course of a test add up to a whole bunch of points. So one of the things you got to kind of train yourself into doing here is remembering to put your symbols when you're talking about the different geometry objects. Good? All right, let's turn the page. Because we want to talk about linear. All right, collinear points are points that could lie on the same line. They don't have to lie on the same line, but they could. So when I look at this first example, all those points are on the same line. They are collinear. When I look over here, is there any way to put a straight line going opposite directions, arrows on both ends, through all of those points? No, it'd have to bend, right? Those are non-collinear. Some of them are collinear, but the overall, all 7 dots are non-collinear. So I want to look at this next picture, and I'm going to ask you, are E, F, and C collinear? Do they lie on the same line? Yes. Are E and C collinear? Yes. Okay, both of those. Here's E, F, and C. Here's E and C. You can see that they're on line F. What about E, F, and D? No. You can't put a straight line. If I go E, F, I got to come down to get B down there. That doesn't work. Are F and P collinear? I got nods and I got shakes. Why? Yeah. Okay, yes, because the line doesn't necessarily have to be there. They could line up in a straight way. For those who are saying no, why no? Nobody wants to say it? It's not drawn. What's the definition? Could. That is the key word. I could do that. So F and P are collinear. So how many points are always going to be collinear? Like, no matter what, I'm going to answer collinear. Say it again. 2. Because no matter what, I can take 2 points and I can put a line through them. So when I put this question on a quiz and I say A and B collinear, do you even have to look at a picture? No, your answer is going to be yes automatically. It's as soon as you put more than 2 that you got to look at your picture. Yes, ma'am. 1 point just like this, then I can't draw a line. But what if I ask you, well, I couldn't ask you if just A was collinear because you need 2 points to be collinear, right? You got to have 2 or more for them to lie on the same line. So just 1 point doesn't work. 2 points, automatic yes. 3 or more, look at the picture. Good? Beautiful. So now when we tie all those points together into a location, into a flat surface, it is called a plane. It's a flat surface that extends in all directions without end. These ones look like, do y'all know what a parallelogram looks like? That's usually the way we draw this. It doesn't have to be. So usually I do that and just draw myself parallelogram. There's 2 different ways we name parallelograms as well, so I'm going to draw 2 different pictures up here. Sometimes it'll just have a letter on the plane, and we would read that as plane P. More often, it's going to give us multiple points on the plane, and then we name it plane ABC. Thoughts on why I would have to use all 3 letters? Yeah. They're all inside the plane. What if I just gave you A and B? Think 3-dimensional. Could my plane go somewhere other than over by C if I tell you just A and B? Could it come out at you visually? Like if I went this way, straight out from the board, that would be a flat surface that included A and B. So you cannot do just 2 letters. You must have 3. And again, to give kind of a better visual on it, if I take this piece of paper and this piece of paper, I have a point here where the staple is on my paper, and I have a point down in the corner, yes? They're on this plane. If I put this other piece of paper right next to it, are they on that plane too? I'm still on that corner, right? On that edge. So the point by the staple and the point on the corner of the paper, if I hold them right, are on the paper that I'm going down with, the same as they are on the paper that is being held horizontal. So I can't just name it with those 2 points because then I don't know, do I want the plane that's horizontal or the plane that's going down towards the floor? Does that visual help? Okay. So give me something in this room, besides the pieces of paper that I just used as an example, that would represent a plane. Whiteboards, yes. Assuming that when we say this, you realize planes go on forever. So the whiteboard extended. What else? Could have been the little whiteboards, big whiteboard, yeah. The posters, absolutely. Give me another one. The floors, is that what you said? Are we good? Floors, ceilings, walls, those all work too. Coplanar, like collinear, co being within, right? Points that could lie on the same plane. Again, could lie on the same plane. So we got a picture of 3 points that are on the same flat surface, but this little guy over here that's not on that flat surface, that is non-coplanar. Really, when you think about non-coplanar, you're thinking kind of 3-dimensional. Like I've got these 3 points, give me a point somewhere that's not on that flat surface, above, below, out to the right or the left, but your flat surface, it's not touching that. So how many points are always going to be coplanar? 3, absolutely. Think about a stool. How many legs does a stool have to be able to actually use it as a seat? Again? 3. Because you got that little triangulation, and then we can put the flat surface on top of it, right? That's why. Because in order to have that flat surface, you got to have 3 points tied together to be able to sit on a stool, to be able to tie it up and say it's in a plane together. So if I ask you on a test if A, F, and E are coplanar, do you need a picture? No, because it's 3 points. But if I ask you A, F, E, and B, then I got to look. I got to see what's on the picture. All right, turn the page. Now, here's where we get a little iffy. I'm using a cube as an explanation, right? When I ask you to name me the plane on the front of the cube, people have a tendency that we let happen because when we get to the polynomial chapter, not polynomial, sorry, polygon chapter, you're going to name polygons by all the corners of the shape. We're dealing with a plane here. I don't have to use 4 corners, do I? How many letters do I have to have? 3. 3 for a plane. What 3 are on the front of that cube? Give me 3 of them. I think H, D, and C are on the back because of those dotted lines. The dotted lines show me what's hidden, and the solid lines show me what is you can see. E, A, B. So kind of, I'm just going to do this. You don't want to do this on your paper yet. But right there, that's kind of our front because those are all solid lines. E, A, and B are. So you could name it plane EAB. You could also, because again, when we get to the polygon chapter, you're going to use all the letters. You could go all the way around the shape. So if you have a cube in your paper or a prism or something like that, and you are asked to name a plane, if you go all the way around like E, A, B, F, I am not going to mark that wrong because it's just common in terms of naming any polygon that you go all the way around the shape. You only need to have 3 though. Here's the thing I will tell you. When we do get to the polygon chapter, it is super important when you are naming a polygon to go either clockwise or counterclockwise around the shape. This chapter, I'm not going to pay attention to it. But I'm going to tell you up front that when we get to the next chapter and I ask you to name a polygon, I either have to start whatever letter I want, but I either have to go clockwise around it or counterclockwise. So I did E, A, B, F. I could have done E, F, B, A. When we get to the polygon chapter, you cannot do E, F, A, B. You can't jump. You got to go all the way around clockwise or counterclockwise. Does that make sense? Just want to tell you that up front so that I don't let you go doing something not right now that then later I'm going to be like, no, you can't do that anymore. So whenever I write them up on the board, no matter what order you give them to me in, I'm going to put them either clockwise or counterclockwise just to make sure we're consistent. Good? Beautiful. Name me the plane on the top of the cube. Don't say it out loud. Everybody write it down. Top of the cube. Check with somebody next to you. See what they used for the letters. Give me one. AGF, I heard. HGF is actually what I heard because A is not on that one. HGF, I'll agree. Give me another one. HEF. Whoa, can't write today. Holy cow. HEF. Anybody got another one? EFG, sure. Anything else? I heard GHE, and then I heard, say this one again, EHG. Absolutely. So any number of combinations could be there, right? Yeah, it doesn't have to be a specific one of those. There's more that I think that you could do, more combinations of how you can get 3 out of those 4 letters, but it doesn't matter which one you do. Just as long as you name it with at least 3 letters. You could have named it with all 4 just because it's a cube and people like to name all 4 letters. Good? Beautiful. All right, so postulate. A postulate is an accepted statement of fact. The first postulate, I don't have to prove it to you. You're going to prove it yourself. And then we're going to ignore the proof whatsoever because it's just common knowledge. Through any 2 points, there is 1 line. Put 2 points on your paper right underneath that. 2 dots. Draw me the only line you can draw me that connects them. What are you going to put on the end of that? Arrows. Very nice. Why do we put arrows? Never ending. Nice. That is why it's a postulate. It's just an accepted statement of fact. It's known. You can't, I can't take you through a why of it. It's just what it is. Postulates are accepted statements of fact. Postulate 2 is if two lines intersect, they intersect in exactly one point. Draw me two lines that intersect on your paper. Right underneath 1, 2. What'd you draw? What's it look like? Two lines intersecting. Can you give me a letter of the alphabet that it might be similar to? Could look like an X. Where do they meet? Right there. It could look like a capital T. But knowing that a line goes on forever, that one that's hitting the top of the T should continue on. Good? All right, last one. Postulate 1.3 says if two planes intersect, they intersect in exactly one line. This is the one that is less fun to draw. We got two different ways of drawing it for you. You follow along with me. You can pick which one you want to do later. First option, draw yourself a parallelogram. Okay. You are going to go to the top middle of that parallelogram. You're going to draw straight down till you're underneath the parallelogram. Ready for this? Everybody's going down underneath the parallelogram? Okay, we're going to go at a little bit of an angle up and to the right. Don't go into the parallelogram yet. So see how I stopped a little bit below? Now I'm going to go straight up out of the parallelogram above, almost like I'm going towards the arrow on postulate 1.3. And then I'm going to come back to meet my original point. Then the line where they meet is connecting that point on the top where it went through and that first bottom point that went through. So there's my line where they meet. Not as easy to draw, right? But remember, up at the top of the page, we had a cube that was full of planes. Yes? Could you draw the front and the top of that cube? I draw my front. I draw my top. And here is the line where they meet. Or like a book. If you draw a book, open book, where the spine of the book would be is your line. So figure out what's the easiest way for you to draw planes. That's your call. Not super important that you are doing great artistic drawings of planes. I am obviously not an artist, so I don't really expect that out of you. All right, we got two review questions right now. I want you to write it down before anybody says it out loud. When two lines intersect, they form a. Two lines intersecting form a. Write it. Look at those postulates. All right, when two planes intersect, they form a. Write it down. All right, now turn and see if you wrote the same words down as the people around you. All right, I'm seeing lots of pictures. You want to write down a word in those two things. All right, two lines intersect. They form a what? Two lines intersect? Point. Where'd you find it? Where's the answer? Through any 2 points, there is one line. Okay. But what about two lines intersecting? Second one, two lines intersect, 1 point. Two planes intersect, what do they form? A line. Perfect. Where's that one? The one right underneath. Exactly one line. Good. How many points to name a segment? Or a line, sorry. How many points to name a line? 2. How many points to name a plane? Perfect. You will find one of the things I do is I rapid fire questions like that because there's definitely things you got to have in your brain that just got to get in there. So I'm going to say them a lot of times. You're going to get sick of asking me how many points do you need to name a line and how many points do you need to name a plane, but it's going to save you when we get to our quiz because you're going to have it in your head then. All right, name the intersection of plane HGFE and plane BCGF. Go ahead and write down the intersection of those two planes. Remember, what do they intersect in? A what? A line. So remember how you write a line. How many letters? 2. What do we put on top of it? Line with the arrows on the end. Okay, so you need 2 letters, line with an arrow end on the end. Where do those two planes meet? Go ahead and write it down. Key is finding those two planes first. Try and see if somebody else has got it, and if they don't, see if you can work together to get it. You're finding the intersection of those two planes. What do you got? G and F. With the line symbol over the top. If you didn't see it, I want somebody to tell me if there's a shortcut where I don't have to look at the picture. Looking at the way I named those, because I used all 4 letters. Nice. We got it here. We got it here. We know they intersect in a line. There's the 2 points that are in both of them. But if you didn't see that, you got to find them. HGFE is up here on top. BCGF is over here. Where do those two planes hit each other? So one of the things that happens in geometry is sometimes it's really visual and sometimes there's shortcuts that are more like, okay, I can just pick out this pattern. You got to figure out which one works better for you. Okay? If I had not named it with all 4 letters, you probably have to look at the picture and find the 2 planes because it's possible I don't give you 2 letters that are overlapping if I only name it with 3. All right, you're going to name 2 planes that intersect in BF. BF is right here if that helps. You're going to name 2 planes that intersect in that line. Ready, set, go. How many letters do we need to name planes? 3. Good. Is there any symbol? No, no line over the top. Lines, 2 letters have a line over the top. Planes have nothing. You can just name them with the 3 letters and be done. You could also, because again, it's a cube, you can name it with all four if you want. All right, what do we got? Give me a name. EAB. No symbol, just the letters. And I had FGC. There were other ways of naming them, absolutely. EABF, GCABF, FGC, like whatever combination of those three. But you had to figure out that it was this one in front and this one on the side. If you are having problems with visualizing that stuff, remember these are three-dimensional objects. You probably in your bag have something three-dimensional. Maybe you have an eraser. Maybe you have just random origami cubes sitting around. Maybe you have a pencil box. Maybe you have a binder, a calculator, something that you could put up there and be like, okay, where exactly is it on that thing that's three-dimensional? So you have more of a visual, a thing in your hand to help you with it. Good? All right. Postulate 1.4 says, through any three non-collinear points, there is exactly one plane. That's just a reiteration of what we said at the beginning. How many points to make a plane? 3. Through any 3 points, we can put a plane. It's the same exact thing as our definition was. Okay? So how many points make a line again? How many points make a plane? Notice I keep cycling that through. Think you'll get asked that on a quiz? Yes. I'll answer for me. Good? Okay. On that picture that is kind of to the right of your how many points make a line, how many points make a plane, this one right in the middle of the page, so second cube down on your paper, you are going to shade the plane that contains A, B, and C. So find the points A, B, and C and shade the plane that contains it. I would shade the bottom, absolutely. A, B, and C are down here. Now you're on that next cube down, so the third cube on the page, you're going to shade the plane that contains E, H, and C. E, H, and C. Third cube on the paper. You're all like looking at your paper like you can't find this plane. Well, it's still 3 points. It's E, H, and C. But what do you mean by it's only 2 points? It's 2 planes. It's in 2 planes right now. But I said every time that you have 3 points, you have a plane. Yes? Okay, think of this for a second. It's what? They are coplanar. All 3 have to be coplanar. What if I took those 2 points up at the top of the corners of the room and a point down there on the corner on the opposite side of the room? Where would my plane have to go in this room to connect to it? Down and across. We have a diagonal plane. It's not drawn, but if I want to take E and H and C, I have to cut through the center of that box and get that diagonal plane. So any three, you're going to have to do a little visualization to find that collinear because maybe it's not drawn in your picture. But any three at any time can always be connected with a flat surface. Is that okay? All right, to that cube that we were just drawing on, name me another point that's in the same plane as A, B, and C. D, very nice. Same plane, she can't answer. Name another point that's coplanar with E, H, and C. B as in boy, correct. Give me another point coplanar with D, C, and G. H. D, C, and G gave us H back. Now, this is the fun one. I want you to write down on your paper before we talk about it. 2 lines that are coplanar with line AB and line DC. What's coplanar mean again? Say it again. They're lines, but where are they located? In the what? Same plane. So you need them to be on the same flat surface as line AB and line DC. Go ahead and write it down. Do we use the lines? 2. What do we put over the top? Arrows. Nice. All right, now turn and talk to somebody else. See if you guys came up with the same 2 lines. Yes, you actually have to turn and talk to someone, please. B2. AD and then we come up with another pair. Okay, I'm going to draw this in there, see if you can see what I'm looking for. If we're down here on this bottom plane, and we want it to be coplanar with AB and DC, we did the typical, the left and the right side, right? Yeah. EF would not work because it is not coplanar, because that's kind of like the front of the cube and then the bottom of the cube, so I can't get them all in one plane. Yeah. CD and BA is where we started. Those are the ones they have to be in the same plane as. How many points to name or to get a line? 2. So a different pair of 2 letters you can connect in that plane. Yeah. DB. And if it was DB, somebody else give me another one. DB, and then I heard AC. So you could come up with lines that weren't actually drawn as long as they were still on the bottom of that cube. Good? All right, we're almost done, kiddos. 1 page left. All right, I want to know if they're coplanar, point B and line EF. Before anybody says anything out loud, I want you to find point B and line EF. Are they coplanar? Yes? Okay. Because you've got that whole plane over there, yes? All right. Now I want line GH, endpoint B. Write your answer. Okay, what are you thinking? Yes. Why? Why are both of those sets going to be coplanar? Okay, so we could have gone like this to make that plane that wasn't drawn. How many points did I name in both of those questions? How many points are always coplanar? 3. So if you recognize that there were only 3 points listed, you can always go to coplanar. So a line and a point, always coplanar, because it doesn't matter where that line and that point are, you're going to be able to put a flat surface that connects them. All right, you're again looking for coplanar, and I want you to go down the list. Do 3, 4, and 5 together, and then we'll talk about them in a second. You're finding those lines and asking yourself, could I make a plane that connects those two? Can I do one flat surface that hits them both? Turn and talk to somebody near you, see if you came up with the same answers. If you don't have the same answers, talk about it. See if one of you can prove it to the other. What do you got for BD and EG? Hearing a yes. BD, EG. You got to slant it through it, right? Okay. All right, what about AC and CG? Yeah, because where are they? They're on the same plane. They're on the front. How many points are actually named there? 3. C's repeat. So it's A, C, and G, 3 points, automatic plane. All right, what about AC and DH? No, you'd have to bend that plane to put those on a flat surface, right? Little preview, that's called skew. We'll get to that in a couple lessons. So we got yes, yes, no there. All right. Now I want to get you up a little bit because you all been sitting for a really long time. I want you to go find a new partner, somebody you haven't just talked to that was right around you. Go find somebody new and do the yes, no's and the always, sometimes, never. Give you about 10 minutes and then we'll talk about them. Anybody out? Talk to somebody new. ahead and do both the yes, no's and the always, sometimes, nevers. All right, let's go through them. Can you have 3 non-coplanar points? 3 non-coplanar points. Number 1, yes or no? No, because how many points are always coplanar? Work with me here. Come on. How many points are always coplanar? 3 coplanar. So can you have 3 non-coplanar? No, because 3 is coplanar. How can 2 points be non-collinear? No, because how many points are always collinear? 2. So this said, can 2 not be, but 2 always are. All right, can 3 points be non-collinear? Yes. If you need that example, I can make these 2 points like this and put one over there that is not on that same line. So if that helps for why it is a yes. Can collinear points, what's collinear? On the same line. Can points that are on the same line be non-coplanar? Points on the same line being not in the same plane. No, because the whole line's in the plane, right? All right, can coplanar points be non-collinear? Can points be in the same flat surface, but not on the same line? Yes. You think about how we drew the original. We did this. These can be on the same line, but that one's non-collinear. All right, and are there points on A and B other than, I'm sorry, on line AB other than points A and point B? Yes. How do you know that? Perfect. So if I got A and B labeled, lines are made up of a series of points. You guys are staying with me now, please. We're trying to go through these. I'm trying to make sure everybody understands them. So I need you to focus with me. Okay, so there's lots of different points on line AB. A and B were just the 2 we chose to give a name to help us name the line. All right, now we got always, sometimes, and never. Intersecting lines are coplanar. 2 lines that go like make an X. Do they have to be in the same flat surface? If I go like this, how many points did I just give? Are those 2 lines in the same plane then? How many points are always coplanar? 3. So intersecting lines are always coplanar. You only have 3 points. The intersecting point and 1 more on each one of them. Do you have more than that? Absolutely. But those are the 3 I can name to show that there's 3 points there. And you can put them as coplanar. 2 planes intersecting exactly 1 point. Never, because what do 2 planes intersect in? Absolutely. 3 points are coplanar. Always. A plane containing 2 points of the line contains the entire line. Okay, so draw me a plane. Here's my line. I got 2 of these points on this line. Is any of the rest of the line out of the plane? It's one flat surface, right? You can't bend the line. So if 2 of them are on that flat surface, all of it is on that flat surface. So a plane containing 2 points contains the entire line because you can't bend. 4 points are coplanar. Sometimes. Think back to our cube. Do I have a cube on this page? Nope, I'm going here. If I look at 4 points and I pick A, C, G, and E, are those coplanar? Yeah? But if I pick A, C, G, and H, are they coplanar? No. So that's a sometimes for sure. All right, and 2 lines meet more than 1 point. Draw me intersecting lines. Draw it. Draw intersecting lines. Ready, set, go. How many points do they meet in? Can 2 lines meet in more than 1 point? No, that's a never. Doesn't happen. Questions? Alrighty, then we have a worksheet for you today. Worksheet 1-2, you have a few minutes here, you can get a start on it. Before you get started, I want to just make sure that you understand the directions on the very first part. All right, so on numbers 1 through 4, it says, first of all, it says use the pictures for 1 through 5. So you see off to the right, you've got that picture that we had in our notes. The first question says, are the 3 points collinear? That's a yes or no. If they are, give one name for the line on which they lie. How many letters do you need to name a line? 2. So you're going to look at, say, number 1, find points A, D, and E, and say if they're collinear. Are A, D, and E collinear? Look at your picture. No, you'd have to bend the line. So then I don't have to answer the line column because they're not collinear, so I can't name the line that they lie on. But if you answer yes, then you do have to go to the next step and name the line that they're on with 2 of the letters. Does that make sense? Okay, you can get a few of them done here if you want to do that. On the back side, I'm just going to make sure that I point out that it says multiple choice above 14, 15, 16, and 17 because it is multiple choice. So you pick one answer out of those. If there is work to be shown, you should show work on multiple choice. These ones, the only one I'd really see is if you needed a picture to help you figure out the answer. There's not like algebra or anything that has to go with it. All right, there we go.